Right, okay. First of the flip learning videos you're probably watching this year, so we're going to jump straight into it and we're going to look at vector addition and vector resolution. You can see how we get before the video ends, and obviously the next part will be on the next video. So we're going to look at vector resolution. Obviously you need to know what the difference is between a scalar quantity and a vector quantity is. You need to be able to define those. You can find those definitions in your textbook. But quite simply, a vector is one that is a quantity that has magnitude and direction, whereas a scalar has just magnitude. Okay. Now, very simple GCSE stuff you've been doing, adding parallel vectors. So say for example you've got a force upwards, and then you add another force upwards, so that one's 5 newtons, and then we add another force upwards which is in 2 newtons, then the total force upwards is, add them together, 7 newtons. So that's dead easy. That's probably stuff you've done at GCSE level. Obviously conversely, so what you're looking at then is you're looking at when we've got anti-parallel, that was called parallel, these are anti-parallel, so if we've got a force up of 7 newtons and a force down of, let's say, 5 newtons, then obviously they cancel and we get a resultant of 2 newtons. Okay, so it's all to do with direction, so we treat one as a negative value, we treat one as a positive value. We're always adding them, but one is a negative, one is a positive. So we assign this as the positive direction, we assign this as the negative, we add them together, we still get our plus 2 newtons. That also tells you the direction of the resultant force. So we can know that the direction of the resultant force in this case is upwards. So that's just basics from GCSE, and hopefully you should be okay with that. So where it is a little bit more complicated is where we have vectors that are perpendicular to each other. So we have a vector like that, and a vertical vector, and we're just going to give these random numbers to basically do some calculations around that. So we'll call that 3.2 newtons, we'll call that 5 newtons. So how am I going to combine these? Well, you can see here that this is vertical and this is horizontal. So we've got to add these and we've got to find the resultant. Well, the resultant is going to be a combination of these two, and yeah, you guessed it, it's going to be a triangle. Now, how do I make the triangle out of these vectors? Well, the hard and fast rule is that we start with the horizontal, we work our way clockwise round a circle from here, and we add the vectors on tip to tail. You'll see what I mean in a second. So we'll start with this one, add the arrow, then we're going to go round clockwise, there's no others until we get to here. So then we're going to add 5 newtons, 3.2, and there's our resultant right there. Now obviously that's not a scale drawing, we're going to talk about scale drawings in a minute because these are going to help you to solve these. So we've got a situation where we've got two sides and we want to know the hypotenuse. Yes, that's right, again from GCSE you can use Pythagoras to work this out, which is very, very helpful. So you can use Pythagoras. Obviously, it doesn't matter. A squared equals b squared plus c squared. So the square of the hypotenuse is equal to the square of the sum of the two sides. So what we've got here, that's our basic Pythagoras, and we could work out that value. I'm not going to do it now because you should be able to do Pythagoras from GCSE. What happens, however, if we don't know one of the sides, but we have, say for example, an angle? And we call that theta. Well, we are dealing with a right angle triangle here because they are at right angles to each other, those two vectors that we initially had, and say we've got an angle of about, I don't know, let's call it 32 degrees. Well, this takes you back to GCSE Mathematics 2 because we need to start being able to use trigonometry. Trigonometry can allow us to work out any missing side here because we've got an angle and we've got our sides. Now let's just identify the sides here, as you would have done at GCSE Maths. So we've got an angle here. This side is called the opposite, because it's opposite the angle. So that's the opposite. This one, it's not the hypotenuse, because the hypotenuse is the longest side, so it's the adjacent. And finally, the hypotenuse, as we've already mentioned, is the longest side of the triangle, which in this case is our resultant. So, good old-fashioned Sohcahtoa. Now, really important, as you get better at using these, you will just see these. You won't need to write out Sohcahtoa and work out each one. You'll just see that it's the opposite, and you'll know exactly which equation to use. So, we look at what we're trying to find out. Now, I'm going to say we're trying to find out the resultant here. Well, the resultant is my hypotenuse in this case. So, whichever sine, cosine, or tangent I'm going to pick, it's got to have the hypotenuse in. So that rules out TOA. Tan. Now, we've got the angle theta, so that's not important at this point, but we need to decide, well, which one have we got? Well, we've got the opposite and we don't have the adjacent, so that then rules out another one. Which one does it rule out? Well, yes, we don't have the adjacent, so it rules out cosine. Finally, we end up with SOH, sine equals opposite over hypotenuse. That's what these mean. Knowing what these means is really important. So sine theta equals opposite over hypotenuse. And at this point, we are into our basic algebra to work out what the hypotenuse is. Working this out, quick algebra allows us to say that opposite over sine theta is equal to the hypotenuse. We can then plumb the numbers into our calculator happily, and we'll get our answer out. So there's two methods so far of working out vector resolution. The third method is one that I've cottoned on before, and I'll just briefly go through that before we finish. And that is a scale drawing. Now, the thing is with scale drawings is they're perfectly acceptable to do at any point because, you know, exam boards expect you to be able to use all these different techniques. So here's the third and final for this video. We'll look at that very carefully. So we've said here, in the initial, we had 3.2 newtons and 5 newtons. And we redrew that triangle to look something like this. With our resultant there. Now, how do you do a scale drawing? Well, you do a scale drawing by essentially working out scale. So the scale here I'm going to use a simple scale as you want. I'm going to say that 1 centimetre is equal to 1 Newton. And it's important to write your scale on there because it shows the examiner what you're actually doing and what you're planning on doing, and they can then measure it themselves. So here we are. So how long do these sides need to be? Now remember this was 5 newtons, so this side should be 5 centimetres long, which is equal to 5 newtons. This side should be 3.2 centimetres long, which is 3.2 newtons. This means that if you draw your triangle correctly, obviously at a right angle because these two vectors were at right angles to each other, then we can quite happily measure the length of this, however long it is, whatever it is in centimetres, is going to equal what it is in newtons, and you can practice and try that just to see and try the calculations. So you should have a go at doing all 3 methods to see if you can work out and get the same resultant force for this example every time. Okay, and we'll talk about what that answer should be in class and make sure that you've got it. Next time we're going to look at more advanced vector resolution when they're not perpendicular, and that's going to bring in some other mathematical techniques from GCSE.